So for related rates problems, the biggest thing is the setup. So for here, we have a 25-foot ladder is pulled away from a house. Okay, so we have a house on one side, the ground on one side, and the ladder on like resting between both of these, and it's being pulled away 13 feet per second. Okay, so it's being pulled away. If you imagine a guy here is pulling, that means if he's pulling, that means this is increasing, this is decreasing. So how fast is the top of the ladder moving down the wall when the base is 7 feet from the house? What that really means, how fast is the top of the ladder moving down the wall? What that really means is, what is DYDT? What is this? So all I did was I put labels for everything that's changing. For example, even though this says 7 feet from the house, that's not a constant. See, 25-foot ladder is constant because the ladder is not able to change. But this is, because this ladder is being pulled away. This is just asking at 7 feet. So, for example, if this ladder was up here and is being pulled away, then this was changing. It was not 7 feet. But 25 feet is always 25 feet. So that means that this needs a label and this needs a label. Because this one, if it's pulling down, this distance is decreasing. So both of these need a label, and that's what I did. I just put a label here and here. And then I said that the 3 feet per second is being pulled here. Now what you do is you write down everything you know. So we know that they want x when it's 7, because that's what it says here. When it's 7 feet from the house, the base. So this, when it's 7 feet, that means it's x. So x is 7. dx dt is 3. Why is that? Because here it says 3 feet per second being pulled away. So that means this part is being pulled away. If it's 3 feet per second, what does this go up to? It matches with x. So dxt is 3. And all this means, dx over dt, this is just x, right? This is just, it's just a variable. So all this means is it's the derivative of that, the change of x over the change of t. For example, you can think about it, x as 7 feet, right? X is just feet, and dx dt is feet per second. That's all it means. It's just this one's in one unit, this one's in another. That's how you can think about it. This one's the changing, this one's the constant. Okay, so what we want is dy dt. I wrote this to help you out, but in reality they wouldn't have this, and they would just ask how fast is the top of the ladder moving down the wall when the base is 7 feet from the house. So how fast is it moving down the wall? All that means is how fast is this distance changing. What does that match up with? It matches with y, but it doesn't want y, it wants the change of y. So then we would write that as dy over dt. That'd be the correct units. So before we start, we can find this missing part, because we can't solve for something if we have something missing. So to solve for that, we need an equation. We could use sine or cosine or tangent, but the thing is we don't have an angle, so we're just going to use Pythagorean theorem, because Pythagorean theorem links all these together. So we have Pythagorean theorem, and what do? We just plug in our numbers. So we said that x is 7, so I plugged that in for x is equal to 25 squared, so y is equal to 24. So now, since we have that, we have our final piece of information, and now we can find dy dt. So how do we get dy dt with these, with just normal? We take the derivative. So here, that's what I do. I have x squared plus y squared is 25 squared. Now we take the derivative. When you take the derivative, it becomes 2x. But where does this dx dt come from? Well, every time you take a derivative, you always have the x. For example, you have x squared, and you take the derivative, it's 2x. So every time you actually do write d, you write d, and then you write, which is derivative, and then you write whatever unit that is. So you write x over d of x, because you're taking the derivative with respect to x. But what is something over something itself? It's 1. So this always cancels out. That's why x squared is just 2x. So you don't even really need to worry about that. But here, we're taking the derivative with respect to time. This doesn't cancel out. So that's why we put that. We take the derivative of x. So here, all I did was 2x. I took the derivative of x, so I'm just going to put dx. But the thing is, where we want time, so that's going to be d, and then whatever that unit was, it'll be time. For example, if it was like radians, if we were looking at an angle, it would be that. It would be dx over d, and then whatever unit. For example, if it's radians, it'd be radians. And that's how that works. So now we have that 2x dx dt plus 2y dy dt, because y squared, you bring that 2 down, you have 2y. Derivative of y is dy, d of that unit, over what we want, d over t, and then 25 squared is just 0, because it's just a number. Now what I did was I just divided everything by 2 to get rid of these 2's. So then what you get is x dx dt plus y dy dt. Now this is the easy part. Now since we have our derivative, we can just plug in all the information we have. So we go back up here and we look, okay, so x is 7, dx dt is 3. We said that y is 24, so I'm just going to plug in all those values. And see, like I just plugged in all those values. And what's good is that this is the only variable left. So then you just solve for it. So you get 24 dy dt equals negative 21. All that happened was 7 times 3 is 21, and then move it over, so it'll become a negative. These are subtracting 21 on each side. Divide by 24 on each side, and you get 24. You get dy over dt equals 21 over 24. That reduces to negative 7 over 8. Don't forget the negative sign. And then the final thing is units. We go back here. We see that this unit was in feet per second, and then that's what you'll write it as. So that's the final answer, because we have the right, if it's negative, and then we have the actual number reduced, and then finally we have the correct units. I hope that helped, and thanks for watching.